Welcome to Aerospace Structures. Today we'll be covering Module 3. We'll be learning how to do contact modeling, which occurs in many different applications in aircraft, launch vehicles, and spacecraft. For this, I have invited Karan, who is an expert in this area. Thank you, Karan.
I have a CAD file, which I'll attempt now to send to you guys. See if this works. Putting in the chat, so it should be class example 4.step. You guys can also CAD it really quick. It's not a hard part, but I'm gonna open this. Oh, I think I've already opened it. Yeah. So it's this is the part. It should look something like this. You're gonna look at this and be like, oh, what are we doing? Today we're gonna be looking at contacts in ANSYS, and generally contacts in FEA. Contacts are pretty hard. They always break. ANSYS Auto does the contacts usually whenever you open a file, but usually those contacts are wrong. ANSYS usually just like bonds all your parts together. So if you actually look at what the CAD file is here, this is two separate parts, right? And of course they're touching at this like little interface, right? But if you don't tell ANSYS how these two parts need to interact, ANSYS will automatically assume it's bonded, which is not necessarily true. So yeah, that's generally what we're going to be going over. We're just going to be going over how contacts work and stuff like that. So first thing, similar to what we've always been doing, is drag and drop a static structural. Oh, and with the step file, sorry, I don't know if I explained, but when you import it in, literally after you download it from your downloads folder, just drag and drop the step file in, and that should work pretty well. That's another pro tip. It's better to have step files when you put it into ANSYS. The other file types, it kind of reads them, kind of not. It's kind of hit or miss, but step files, I've never had an issue with the step file whenever I exported. So I recommend. So you can see this is our geometry that we imported. And another thing, the way to rename modules, just double click this and you can like contact. Okay, so the way you connect it to your geometry, so this is the first time we've imported it, is you just drag and drop it to geometry. So you see this, you click it and then drag and drop it in. And so that's what it's doing here, is it's effectively sharing the geometry here into this static structural module, right? And another thing you can do is, let's say I make another static structural module here. What I can do is I can drag and drop this geometry into this static structural, right? And so what would happen here, right, as you can see these little lines, is if I update my geometry in this, it will actually update all the downstream components, right? And so this is actually useful in certain cases, if you have to run a lot of models in parallel. Like for some examples, I know if you run ACP, which is a composite solver, you can drag and drop model inputs. You can run one for model, and then for the ACP layout, you can have it where you drag and drop the model into the static structural, and then so you can run both a static structural and an ACP. That's pretty useful. Anyways, I'm gonna get rid of this static structural and just keep this model, and I'm just gonna open it. Any questions so far?
Can you rename when you do multiple models from the same geometry? Are you able to name them, or only your contact example?
Yeah, you can rename this static structural. So if you click on the static structural, you can rename that. So you can say model variant A or model variant B. I think that'll be helpful for your guys' homework for part C, because you're running a clamped plate versus a simply supported plate. So if you have one model, you're not really changing much in the model. So what you could do is, wait, this is still open. Give me one sec. But what you could do is actually you could duplicate a static structural module, right? Because most of it will still be, the same. So you don't have to update it. Okay, so this is it. It's opened up. All right. Yeah, this is how you would duplicate. So if you click this arrow and you see this duplicate, if you click duplicate, it'll actually duplicate everything. And then you'll have everything already duplicated. And you can then make your small edit for running clamp if it's fixed. So yeah, that's a pro tip. So you don't have to redo everything for just one small change. Yeah, that is honestly the TLDR of ANSYS, is the GUI and ANSYS itself. The great part about ANSYS, I think, is it's very easy to set up and run a model. It's relatively straightforward. Especially if you run Abacus or FEMAP, those require a lot of intensive work to even set up one model. The good thing with ANSYS is you can immediately set up a model pretty simply. But I would say the bad thing and the trade-off you're making there is that it auto assumes a bunch of things, right? So look, I've just, right now, literally all we've done is I took that CAD file and I opened it in model. But you can see it's actually already defined a bunch of things, right? And I haven't told it anything. Yeah, it's already defined it. So what you'll actually see here is, standard as before. You can see these two components. We're going to keep it structural steel today. You can define it as aluminium if you want, or, you could go into the engineering data and change it. But, the purpose isn't here to show you the stresses or anything, at least not yet. It's just show you sort of how contacts operate. So yeah, we're just going to leave it with structural steel. So that's fine. Coordinate system is fine, but if you open the contacts here, you can see actually ANSYS has already defined a contact for you, right? You haven't really probed it to define a contact, but already defined a contact. And if you see, look, it's selecting this, and this is another pro tip. If you see this contact body view and this target body view, you can actually see which two surfaces it's interacting with. So you have contact here and target here, right? And so these two surfaces actually, it's putting as bonding, right? So that's it's already basically defined it as something. And so now you might ask, like, okay, what is bonded, right? But I'm first going to take a step back. Usually when you get more experience with ANSYS, you might be able to look at their auto setup and be like, oh, that's good or that's bad. But because today's example is to show you how to do context, I'm actually just going to go ahead and delete this. So I'm going to delete the contact region ANSYS created for me. All right. So now there's no contacts, right? So I'm just going to leave it with an auto-generated mesh. This part, again, is designed very easily to mesh. So all I did is right-click generate mesh. But if you go to display style, change that to element quality, you can look at like the element quality. I mean, it shows red, but it's literally 1, right? So it's a very good element. You don't have to worry about element quality here, right? So the question here though is, let's say I apply a force on this face, right? So let's say, okay, I'm not oriented like this. So let's say I apply a force on this face. Let's say it's 10 pounds. Okay. Yeah, let's say it's 10 pounds down. So 10 pounds into the surface. So like this. And then right click insert. So this is, by the way, a reminder, static structural is where you add all your boundary conditions. And I add a fixed support to this surface. Okay. So all we have right now is force and fixed surface here. What do you think is going to happen here when you run this model? Right. We've given a boundary condition and we've put a force, right? So everything should be fine. Is that true? My force should be. See, Matthew, you've raised your hand.
Yes, so sorry, it looked like you changed the location of the force. Are you putting a force on both faces so that
I'm gonna put it on this stuff, on the other body. Sorry, I did change it. Yeah.
Okay.
So it's fixed on this surface, and this is the force.
I guess if they aren't considered to be bonded and there is like relationship between the two, it would seem like the one that has the force on it will just pass through the one with a wall.
So let's run it. Let's see what happens. Okay, so you can see whenever you get this red arrow, red lightning bolt, you guys may have seen this as well when you're doing some homework. This means your model had an error, right? So let's plot total deformation. Let's see if even it got anywhere, right? And you can see current result file may not contain data. So it really got nowhere, right? And so if you click this message in the bottom right here, you double click this, it shows you sort of what errors there might be. So these like highlighted ones are the bad ones. So it says, here, solver pivot errors or warnings or errors have been detected during solution. This is usually the result of an ill-constrained matrix, possibly due to unreasonable material properties, an under-constrained model, or contact-related issues. Check results carefully, right? The reason it says this is sometimes ANSYS gets most of the way of solving it, but then it breaks, right? Here, what we know, right, and from what you said, Matthew, is we know that our part is under-constrained. So what's really going to happen is probably there's going to be a force on this, and this part is just going to go flying off to infinity, right? And so the key thing here is, we're not running a dynamic sim, right? So we're not simulating dynamics, we're simulating static structural. So key point there is it should be static, and this model is not static, so it's ill-constrained. And I think the professor went over a similar example, like how would you constrain like an airplane wing? That's technically, everything's free, but you can make assumptions like that, like the fuselage to wing connection, that's a fixed constraint, right? So that's how you get away with, even free bodies. You kind of break down the problem even more. But yeah, so you can see this is breaking, right? This is breaking. So let's go ahead and add the contact, right? So let's go ahead. So the way you add contact is in connections, right click, insert, and manual contact region. And so when you create that, it's going to give you a contact and a target, right? And now this is a pretty common question I get asked. Like, what's like the difference between a contact and a target, right? There are some nuances here. For the purposes of in this class, I would say like a general rule of thumb is that you basically give your contact surface, you give your contact surface to the less stiff component, and then you give the target to the more stiff component. So let's say this was like aluminium 61 and 75, you would assign it accordingly, right? But in general, it's probably not going to matter for the stuff we're gonna do, like what contact or target assignments you have. But there's also a way to flip it. So you can flip contact and target. I can attach some more reading resources on it as well. Yeah. So what I'm going to do is I'm going to select this as contact. And so you can see as soon as I've selected this body, let's say, the body is like very hard to reach. let's say I want to select certain, you can use this contact body view. So as soon as I clicked on the body, you can see this body shows up in the top right. So effectively you have like this triple monitor set up on one screen going. So I can select this surface, I'm gonna be like, hey, this is the contact, and click apply, and you can see it apply. And so I want to do the same for target, so I click this, and then I click on the other surface, right, and then I apply. And so this is what ANSYS had on the start, but it's always better to go and do it yourself, because sometimes in more complicated models, it's not trivial as to what you're contacting. Okay, so what are the thoughts now on what's going to happen? So we have the force here, and this is fixed on this corner. What do you think the deformation is going to be? Or any thoughts? Yep, Matthew?
I guess one thing I would be thinking about is like if I were to take this to like the real world, I'd expect that your face A, your part would just kind of spin off. I'm not sure if it's got enough of it over the other part for it to stay on there. I think it might just kind of fall off the end.
Okay, yeah, that's a good guess. I can run the model and we can see what happens. So you can see actually the way it's deforming is it's deforming kind of like a cantilever beam in a way, a weird cantilever. But yeah, so the model is sufficiently constrained where it's deforming in a reasonable shape. So why do we think this is? Like, what is a bonded, or I guess a better question is, what is this bonded contact doing like physically to the model? What do you think the criteria are for, if I show my mesh again, get rid of element? Yeah, like physically, what do we think are happening at these like nodes and elements?
Since this is a bonded contact, it's not going to be able to detach, which is what
so critically, that what a bonded contact is doing is that relative to both surfaces, there's no separation and no sliding. That is what a bonded contact is physically doing on this part. So effectively, it's attaching these two parts together, and there's no separation, no sliding. So basically, all the forces are transmitted for when I'm putting a down force here. This part is still also deforming. You can see this here. This part also deforms, right? And I put a fixed support here, and from last lecture we talked about fixed supports. Like what a fixed support here is doing is it's fixing all these nodes and elements, and these nodes and elements can't move, right? So this is like the end of your cantilever beam, right? So sorry, not the end, like I would get the part attaching the wall, and this is the edge. So yeah, that's what a bonded contact is doing, right? But let's say you don't want a bonded contact. Let's say I don't want to bond it, but there's other things you can do. So what I'm going to do here is I'm going to actually move the force. I'm going to move it onto this surface and apply it on this surface. So the force is here, and then this is the fixed support now. And these are the forces on this, and the fixed support is here. Okay, so there's other stuff you can do. So if you go back to your contact that you've created, you can like click this type, and there's different types of contacts you can have. So there's no separation, frictionless, rough, and friction. So let's go to no separation. What do you any thoughts on what no separation is? If the criteria are like separation and sliding, what do you think no separation is? Yep.
Only slides?
Yeah. So it's constraining those nodes to not separate, but yeah, it can slide. So if I go ahead and run this, right? See, you're getting a solver pivot error here, right? Because now this part is deforming down, right? And so this part is just ill constrained, right? Like, sure, it's not separating, but as soon as this deflects even a little amount, right? Now it's at an angle, right? And so there's no separation, but it's probably sliding off to the left. And yeah, with ANSYS, like, oh, actually, could you see that? Let me see if I can scale up that result. No, I can't scale it. Must have not solved. Sometimes, yeah, ANSYS like tries and gets you a result, but it's not like a real result. It might even be like the previous result. But yeah, so yeah, that's why it's ill constrained here, right? Because you have no separation, but you have sliding, right? Okay, so that didn't work. What else? We have frictionless, right? What do you guys think frictionless is? I think frictionless is a hard one. I think I might just give the answer with this one. Frictionless is like, if you think about it, frictionless actually is like, so there's no friction, so that means you can slide, and frictionless means you can separate. So what frictionless really does is it prevents bodies from going into one another, if that makes sense. So effectively it's saying like, actually ANSYS, whenever you run a sim, let's say you don't have any contacts between these surfaces, there's nothing to tell the part that it can't phase through another part, right? Because you haven't told them that there's a contact there. So you would need frictionless to do that, to prevent it from. And then you have rough, right? So what rough does is it allows separation but prevents sliding, right? So if I move my force to this surface and change it from vector to components, and I'm going to put it in the x direction. You can see what's happening here, right? You're just getting some phasing of the part. And you can see this deformation actually. You're getting a deformation in 1.6 e to the 6. So this is actually like a very not real deformation. This is just the part is like, you know, if you actually animate it, like if you put true scale, right? So true scale is 1.0, right? Your part is effectively going off into infinity almost immediately. So you can see how, like, you know, constraining your model poorly can lead to pretty bad results. And so you need to think about what contacts you're putting in on surfaces and when they're applicable. So what rough here is that there's no separation. There is separation, but no sliding. And then finally, you have frictional. So frictional, you define a frictional coefficient. So this is effectively like simulating a surface. So, you know, if you have like metal to metal or whatever, so you can add a frictional coefficient like 0.3, you know, and then run it and then solve it. Yeah, that's kind of all I wanted to go through today. I was also going to go through some like meshing stuff, but I think I had gone through that in the other lectures, like stuff like sizing. So if you click a body, you know, you can size different bodies, different sizes. So if I change this is 0.4, right? I'm gonna make this mesh. Right, what I did there is you can see this became a finer mesh, but what I did here is I right click, insert, and then sizing. And then this allows you to change what size your elements are. You can set like a number. And there's different ways of meshing too, so you can use the method. If you click it, like I think ANSYS by default doesn't automatic, but let's say you want to mesh only text, right? You can see now it's meshed as text, right? You can see these both have different mesh types. So I would say like the thing here is like meshing won't be, you can see actually like how, you know, stuff with text is different, right? And then actually another interesting thing is if you actually go to advanced somewhere. Oh yeah. So if you go into mesh, then you go into quality, and then if you go into quality mesh metric, you can click element quality as a mesh metric, and then it will generate a table. And you can see how all different meshes will have different qualities. So I click like 100%. You can see there's actually like a far fewer number of elements for this, but all of these elements have like very high quality mesh. As you click through, you can see, okay, these elements have this quality, these elements have this, and then you can see as you go down, you're getting like poorer and poorer quality elements. So I think this is a pretty cool view of seeing how your mesh works. It's cool statistic, like just like a normal distribution almost.
Quick question.
Yeah, what's up?
In ANSYS when he first loaded this geometry into ANSYS, it predetermined a contact surface. What kind of contact surface did it predetermine? Like what was that friction setting?
Yeah, the first setting that it automatically does is bonded.
So it's always bonded. Okay.
I can't guarantee it was bonded, but I think whenever you open it, yeah, it does automatically put it as bonded. Like usually ANSYS doesn't really. I think the newer versions actually have some of that, but I'm not exactly sure. Most of the times when it gets defined, yeah, it looks at surfaces which are touching and it's like, okay, these are bonded. Great.
Gotcha.
And so you might be able to run a surf like I've seen this happen before, is where someone will import a geometry from CAD and they'll be like, okay, great, and then they'll apply a force and they'll get like stress results, right? But you might be getting stress results because your contacts aren't realistic compared to the real world, right? And that's I think that's pretty dangerous. Like more so just like you want to know what you're putting into your model, right? Before you run it. But yeah, this is what this would be the default where it's bonded. So it's effectively acting as like sort of on top.
Gotcha. All right, thank you.
Yeah, that's all I wanted to go through today, so not much, but did anyone have any questions with the homework that they wanted to ask?
Yeah, the main comment I have is contact is used extensively in the industry, particularly for modeling seals, pressure vessels that may have two parts not bonded or bolted, but they interface with each other. So this is extremely important analysis to learn. And I'm going to come up with a very simple example to illustrate it.
Yeah, I think it's cool seeing that, like, you know, most contacts you're putting on this geometry, like, will not solve, right? And it may seem like some of them genuinely, like, you might think through and it's kind of confusing as to why it's not solving, but it shows how common pivot errors are. But then, you know, a lot of people resort to just like, okay, I'm having a pivot error, I'm just going to fix my part, which is not always, you know, conservative and not always true to what your part is. So sometimes it's really hard to get the context to work. So it's important to think through what's happening. And yeah, like the professor mentioned, like, you know, let's say you have, I guess I don't have a hole in this part, but let's say you have a bolted joint. Same with the connections tool, you can right click insert and then join, right? And so this joint is effectively what it's doing is you can model bolted joints as joint set, right? And the way you can do it is, you know, you can maybe make it fixed, which is like, you know, you're just saying like, hey, this is basically a fixed connection. That's how it works. But realistically, the way you do it is you give your bolt stiffnesses and then you model that as a bolted joint. We might touch on that later in the class, but I just wanted to give like a basic run through for context. Is anyone able to download ANSYS onto their personal computers? I know there's a way through my Viterbi. This is a personal version of ANSYS, like I have running, or like through the school. So I know it's possible for sure. Okay, are there any other questions, or did anyone have questions on the homework that they wanted to ask?
I had a question. And first of all, thank you for doing these tutorials, they're really helpful. On the problem with the square plate being clamped on all four sides, were we supposed to do that with the fixed support, or is that like kind of a new way you were supposed to do that one? Okay.
So let me open the homework. So you're referring to part C. Yeah, so removing the 2-inch hole, and then we're loading it with now 10 psi normal to the surface, study in 2 configurations, all sides clamped and all sides simply supported. Yeah. So if we actually go into ANSYS here and we're looking at like all the supports I have, right? If you look at it, right, there isn't necessarily a clamped support, but I would ask like, or maybe I'll turn the question on you, like what is physically a clamped support? And do you think a fixed support is a reasonable assumption of a clamped support?
Yeah, but my assumption was it would be reasonable. Like
Yeah.
kind of whenever I did the analysis for fixed and then simple, I kind of got like the results I got weren't what I was expecting, kind of like from my hand calculations. Yeah, so I feel like something I did wrong, but I don't know exactly, what it was.
Yeah, no, that's fair. Do you know what your like percent error was, maybe?
Yeah, well, let me pull it up real quick.
So I think it's better to use everybody's time differently. So I believe, Edward, if you have further questions, put them in Piazza or contact Karen separately. Because debugging models in a class setting is very hard. I'm telling you, I've done it. Right. So it could be unit error, it could be geometry error. There's so many things that can go wrong that I'd rather take more conceptual questions now. Edward, if you don't mind.
Yeah, totally fair.
Because trust me, I've created models and I spent like a month trying to debug them. So here, what we expect when we grade you, we expect you not to get it perfect, but to show us that you have a good understanding of how to set up the model, that you can rationalize your results. If they're off, explain why you think they're off. If you can't figure what's wrong, I don't want you to not sleep, is what I'm trying to say. Because Karen and Karen was working on a problem last year that was driving me nuts, buckling, and it was driving me nuts too. I was every night thinking about it forever, right, Karen? Can you tell me more?
Yeah, no, definitely a lot. Like anything can be wrong in your model. It could be like, you define a material property and you actually need to find it in PSI as Pascals. I think a thing to understand here is like, I would, and the reason I'm trying to do more hand calcs too, it's harder with more complicated problems, which we'll get into later, but the hand calcs really let you ground it. So even if you have like 15% error with a hand calc, I think the important thing is that you're in like, you're within reason, right? And the thing is, the reason, like what does within reason mean? That is kind of engineering judgment. And I know that's not like the best answer, but really sometimes, correct order of magnitude is good. Sometimes, like getting within like 15% is good. So I wouldn't worry too much if you're like a bit off. I would just make sure like, you know what you're probing. You're not just like, let's say a hand calc says the highest stress is meant to be somewhere, right? But then you're probing the highest stress in another location. That would be like, okay, like that could be something that's erroneous.
Yeah, makes perfect sense. Thank you guys.
Yo, Karan,
But
quick
I didn't have
question.
anything else I wanted to cover. Yeah.
Let's say I want to duplicate a model, so I have like 3 separate models and each one has its own mesh size, just so I don't have to keep rerunning my model. Can you do that by duplicating?
Wait, can you repeat that? So you said, so yeah, you can duplicate models by, so on this B module, you can see like I'll click the arrow and I'm going to click duplicate. So I'm going to keep the upstream connections. And then look, that I've created a copy of this model. And so if I double click and open this, it'll be the exact same. Basically everything in this model that I did will be the exact same.
Okay, so you can go in there and like change your mesh size.